And he's back again. This time, guys, we're going to be continuing the escrow contract series that I started yesterday, where we sketched out some architecture and made some initial stabs at some pseudocode. And today we're going to try to make it more concrete. And also, very importantly, um, today I have coffee. And with coffee, there is nothing in the world that one cannot accomplish. So that being said, we can jump back into some code and I can give you some updates. I did take the afternoon yesterday to make some mappings from the original pseudocode files into some actual implementation. You can see here I copied and extended and adapted the interface definition that we wrote yesterday. And now we have some more fields, but we also have some constants declared in script. So we're writing real script code here now. And so you can see some of the static constants that map to some of the values. I've added some new ones, including things like when can bond increases stop happening? When can bounty increases stop happening, rather? And what do the state variables of this contract actually look like in practice? Then we have a constructor with some sane defaults. So maybe that's a little bit more clear. And what I've been doing now is mapping over some of the primitives, mapping over some of the pseudocode into actual methods. And I was writing a few of these just now, and I was like, this is really interesting. And, yes, I have this one down here still from the counter, which is, of course, from the meter repo where we started. You'll be able to follow along, and maybe I'll put this up in the chat. Let me just see if I can't do that really quick. You'll be able to follow along in this repository. I'm going to give you a link here. It's going to be github.com/p2p/Babbage escrow. And that link is going to be in the chat. Link is also going to be on the screen for a second, if I can manage to do that. So there it is, right? You can check out that repository if you want to follow along as we build out Metanet Escrow components. Let me send out a tweet as well, just to let everybody know. Babbage is live again, working on some escrow components, making them more solid. Boom. Follow us on X if you want to get notified when we randomly go live at random times to build random things that are probably fun and possibly useful. In this case, I think it's almost definitely going to be useful if we succeed in our endeavors together. I always tell my team, here at Project Babbage, we are a research company. And so that means it is extremely paramount that we do fun things. And if those fun things are useful, that's also, kind of it's a plus, right? So, yeah, back at it here with some of this stuff. I can walk through what we have so far. Again, we have a constructor so far, and I'm going to close this out because having two things open at once is a little too much for this monitor. I usually use an ultra wide, but for live streaming we use the 16:9. All right, so what are we looking at? Well, we got an Scrypt contract, and I thought I wanted to make this really simple. So when you construct this contract, you are a seeker of services or products furnished by a furnisher. And if there's a dispute, then the platform comes in to mediate. So that's the context of this escrow system that we're building. So when you construct this, you obviously need to pass in a few, just a few parameters, just this many. And that way your contract can be set up the way that you want. What we're going to be doing in this live stream is we're going to be writing all of the methods of this contract to actually enforce all of the things that would make sense in order to ensure that the contract rules are followed by all of the participants to facilitate the services and products being exchanged under escrow. So you want to set up a contract. There are some things that you absolutely, definitely, 100% for sure need to put in. Who are you? What is your public key? What platform do you use for your escrow? What does that platform charge? Right? What work do you want done? Just describe it, right? Whether it's plain English or maybe there's a protocol for this, but what work do you want done? And when do you need it done by? Okay, pretty much every time you make a contract in this system, you're going to want to say those things. What's your minimum bid? Who, when they bid on things, what's like a reasonable minimum bid for your work, right? That you want to have done. How many people max can bid in total, right? You can specify those. Then we get to some configuration parameters, and this is where it gets a little more involved, but we think about all the details because we need to, because we're going to enforce them using Bitcoin script. And if you enforce something with Bitcoin script and it's ambiguous, then it just doesn't work. You gotta be clear about everything. That's why we need these. So do bounty solvers need approval? So can someone start work without talking to anyone, and then the first one to just say, hey, I finished it, right? They get all the money. Or do they need approval? Must your escrow service, are you asking your escrow service to be fully decisive? If you lose all your money. If you win, you get all your money back. Or can they split the baby, right? We talked about that already in the last live stream. Right. Furnisher bonding mode. If someone messes up, bonds, things related to that. How much bond needs to be there? How long do they have to accept the bid? How long do you have to review the work? What are the units of these delay? Are you talking about blocks? Are these delays in terms of blocks, or are they in terms of seconds? Those are the two delays supported by unlock time. So two different time universes. Then we got an approval mode. Who can approve a worker to start working? Is it just you? Is it the platform, or is it either one? And then you got contract type. Is it a bond? Is it a bid type contract, or is it a bounty type contract? And then I added a couple things. Bounty increase allowance mode. So if this is a bounty contract, who may increase the bounty? Is it anyone? Anyone may increase? Is it just you? Is it the platform? Is it either you or the platform? Well, we'll have to think about that. And then cutoff point. When is the latest point where someone may make the bounty higher? So this is where we're going to get started, right? So then we got some state variables, and we initialize always at the initial state. All contracts begin in the initial state. And there's no bids at the beginning. Okay. No furnisher key, obviously no work completion time, and no work completion description. All right, so first method, seeker can cancel the work beginning. So I coded this up and I was like, okay, this is pretty simple. So first we're going to require that the contract is in the initial state, meaning it has not gotten to have some bids accepted yet. And then we're going to require a signature from the seeker. So by providing a signature, the seeker is saying, yes, I want to cancel this contract. And I want to, I'm not going to put any constraints on the outputs and force the outputs to go to a particular place. So that's where we got to. Then, and I have this silly stuff here. We can get rid of that. Okay, I'm going to leave this one down here just in case I need to reference it. But it is not part of the contract. All right. So what we're going to be doing is writing more methods, and we're going to be starting with all of the methods that are in the seeker pseudocode. So if I'm a seeker, here's the things I want to be doing, and I started with one already. So seek is what a seeker does when, hang on, did I click on the wrong? No, I'm in the right place. I just need to find what am I doing, right? Am I losing my mind? I might be losing my mind, guys, but that's okay. Because this is already done. And essentially, you would create a contract. So there's the constructor. That's essentially what the seek thing is. It constructs a new contract. Then we have the get my own contracts. Well, that's overlay related, so we'll do that later. It's not actually doing anything with it. It's a read operation, not a write operation. And then we implemented the cancel before accept, and that's already done. So then we moved on to increase bounty, and that made me think, well, I as a seeker might want to increase a bounty, but some other random person in the world might want to increase a bounty. So therefore, I decided to code out some of the additional things there because, that's what you do, and that's why we have all of this stuff. And pardon me for moving around as I was selecting that. Right, there we are. So now it's there. Okay. You can see that these are different things that apply to bounty increases. Firstly, can an increase happen? And if so, who can increase the bounty? And then, when can the bounty be increased? So this is where we begin to write some new logic. So this is a method of the contract that is going to say, who can increase a bounty? Well, in this case, it's anyone. So a signature is not required because it's anyone. But certain constraints must still be met, and we need to enforce those constraints. The first one is, right, we have to say, here's a number. And let's talk about what the end result will be before we get into all the restrictions, which we're just about to implement. But basically, when we talk about increasing a bounty, we talk about doing nothing other than making the UTXO more valuable. We're not going to change anything else about the state of the contract, except now it's just a bigger contract. It's got more Satoshis attached to it. So you pass in how many Satoshis you want to increase the bounty by. And then after that, right, well, first, I guess, yeah, we make sure that it's more than 0. If you pass a negative value into here, you could call the contract as anyone and take all the money out of the contract. This is not how you win friends and influence people, but if you did this, right, you've got to have this check. So if you're writing a smart contract, for anybody that's writing a smart contract, don't let somebody pass a -1 or a -1,000,000, because then you're going to require, right? And now we'll get into what this is actually requiring. It says we're requiring that a state output gets built. And for the state output that gets built, we're saying assert the hash of the outputs of the new transaction that spends the old one is equal to the hash of the state output in this case, which is the new output, where the value of the UTXO from the old transaction plus the amount is equal to the value of the state UTXO in Satoshis. So what we're saying here is when you have the new UTXO, it has to have as many Satoshis as were there before plus the amount. So you pass the amount, and that's how much you want to increase it by. If you passed a negative number into here, for example, well, a positive plus a negative is like a positive minus. So you're going down, and obviously you don't want that. So you make sure it's more than 0. That's the first check. Then make sure you're actually dealing with a bounty contract. And then here I just have, make sure that the allowance mode is anyone. So make sure you're dealing with a bounty contract that anyone can increase the bounty. But before we just allow this to happen, we should also make sure that the cutoff time has not been elapsed. So that relates to the state of the contract. So we want to enforce the cutoff time. Nobody can increase a bounty after the state of the contract is beyond a certain value. So if the bounty increase cutoff point is equal to cutoff point when the bid acceptance, meaning once the bid gets accepted, no more increases to the bounty. If that's the case, then we want to assert that, well, what is the only state of a stateful contract where, in this case, the bid is not accepted? In this case, it is the initial state. So I'm going to assert that the contract state is equal to the initial state. So now we have successfully implemented the check associated with when it's not allowed to increase the bounty after the state has gone, after the bid has been accepted. Let's now implement the other cutoff points. So we got bid accepted, we got start of work. In this cutoff point regime, we want to require that either the initial state is here, or because, again, you can increase the bounty until work actually starts, another state is also valid. In this case, the bid accepted state is valid. Okay, so now we've implemented the second cutoff for bounty increase at regime. Okay. So now we'll do the third one. In this case, it's going to be submission of work. So somebody could increase the bounty after work has already started up until the point that work is submitted for review by the by the seeker. In that case, and I'm going to copy my assert because I think we know where we're going with this. It is okay for the state of the contract to be initial, bid accepted, or state of work started. And we have, I think, one more to implement. Bounty increase point. So in the case of submission of work, then we just need to require that the state wait, so you can, let's see, is this correct? Hang on. Have I messed up? I might have. In the first state, you can increase the bounty until a bid is accepted. If it is okay to do that, right? Okay, until submission of work. Oh, have I duplicated? I see. I have. What's the other one? Acceptance. I forgot. I did it wrong. I think it's acceptance. Yes, right. Because now what you're saying is even when work is submitted, but before it is accepted, you can increase the bounty. Right. And now we have implemented all 4 acceptance regimes for the contract. We've implemented all 4 cutoff regimes for the contract. Okay, here we are. Let's see. We enforce the regimes for cutoff. This method allows anyone to increase, and I think this method is now complete. This method allows anyone to increase the bounty. Now we want 2 more because there are 2 more individuals who might be able to increase the bounty. One is called seeker increases bounty. Oops. No, I did that wrong. Yes, this one down here. Seeker increases bounty. Okay. So I've just copied this method because, well, if the seeker is going to increase the bounty, we need a seeker signature. And we also, and yes, we will check these. So we make sure the amount is more than 0. Can a seeker reduce the bounty? I'm not going to support that. No. You put up a bounty, you can increase it, you can't decrease it. If you can, you're making it, yeah, I'm not going to support that. Somebody can fork this code if they really want to support that. Making sure it's a bounty. And here we want to make sure, because we know it's the seeker here in this example. The seeker should use the increase by anyone if the regime is anyone. Right? If this is anyone, then the seeker can act as anyone and call the other method like everybody else. And I don't need their signature. So I'm not going to allow them to use this method. Or is it a good idea to allow them to and differentiate? Maybe it is. I guess we can keep it. I don't know. It's no real harm. So we'll allow this regime to pass, or allowed by seeker, of course, or seeker or platform. So anyone, seeker, or seeker or platform, pass. Now you're basically saying if the seeker is here, this is fine, right? And of course, I forgot my method decorator. Can't forget that. So when the seeker increases the bounty, we do that. We still enforce the cutoff. Okay. And then we go and we also check sig. Okay. What's wrong? Do I have it flipped? No, I don't. Seeker key. Yeah. And the error is something like seeker must sign. To increase bounty, right? Got to make sure you are who you say you are. And then you make sure the state output's equal, right? Now, this means there can only be one output. Just thinking here. Maybe we want sig hash single because we don't care about the other outputs. Sig hash single is a much better regime than, yeah, that makes sense. Okay. I'm just thinking for stateful UTXOs, there could be other outputs, and the hash outputs would not actually match if you signed with sig hash all and had, for example, change. Now, I know that Scrypt supports this build change output business, but it's very limited and very cumbersome. And just it's not, signing with sig hash single is generally sufficient when all this contract cares about in this case is the single output. The wallet funds whatever, and as long as the Satoshi value is in here, the contract doesn't care, and the wallet captures whatever in change. So as long as the input is input 0 and the output is output 0, for example, it matches up and it's all fine. For that reason, I'm going to bring back, I think, what is commented. Anyone can pay single. Right. So stateful propagation can still happen in a secure manner with sig hash anyone can pay single. Here's this. Okay. This does not require any stateful UTXO propagation, and therefore no sig hash is enforced. But this is related to the signature that happens with this.ctx when you come to set this up. Okay. All right. So a seeker can now increase the bounty, as can anyone. I'm going to copy this method once more because, and by the way, the reason why I'm not going to drop any of this into helpers just yet is because I'm being very conservative with my usage of Scrypt. And the reason why I'm doing that is because I don't know enough, I don't have enough faith in the Scrypt compiler uh, to start doing things like dropping this into a util. I know that this could be a util, and the programmer part of my brain, the part of it that's still left, anyways, uh, tells me that I should put this into a util, but I don't know if calling into other things inside of a uh, I've not been able to get that work, and I've run into issues in the past, and therefore it's going to be a bit of a longer contract. But everything that relates to the constraints applied to every method is going to be repeated across all methods, at least for now. Uh, one of my goals with this library is that once it gets used, hopefully we can get more people looking at it and improving it, and maybe even invite some of the Scrypt people back into the BSV space. That would be nice, because I'm not the one who made Scrypt. I just use it, and if I could tell Xiaowei something, I would say something like, uh, "Was really fun in San Fran that one time when we had this hackathon, and I think a lot of people showed up and appreciated what we had been doing, and you should come back, and we should do more of those kind of things, uh, because." We over here at Project Babbage in Oregon are not too far away from you, and we miss you, and we want you to come back. So help build the Metanet, because we have to do this stuff in a standard way. Let's keep going. A seeker can increase the bounty, and also a platform might be able to increase the bounty. So in this case, it becomes platform signature, and I know that you could probably put this into a conditional branch. Oh wait, would that be super easy? I don't know if that would be super easy. It probably would be a little complicated to enforce the set of constraints on this if... Oh, wait. Can I combine these methods? Do I need to copy and paste all of this code one more time? Do Scrypt methods support optional parameters? Because if they do, I could even add a little question mark next to the signature and have only one, and then I could put all three into here, and but let's think. If I wanted to support seeker increases bounty, it's simpler. I'm just going to say seeker increases bounty and platform increases bounty. It hurts I know that the script size is going to be larger. Somebody will have to come along and optimize this, because I'm on the fence about trying to unify all of this code. And I know that if I knew Scrypt a little better, and if Scrypt was a little more compatible with everything, the new stuff, we could probably make it work. Might even be possible, but enough being idealistic, I guess, for now. All right, we make sure that's there. It can be anyone. It can be platform. And then that can be seeker or platform. Those are the three options if the platform is going to do it. We validate the mode, and then we check the sig for platform sig against platform key. So the platform can increase the bounty. Okay. And again, we're using sig hash single and sig hash anyone can pay. And we're verifying that the amount and the output is correct on the single output that we do care about. And I think that's the correct way to do this. Okay. Let me check in with chat really quick, and then we'll get into some new methods. Let's see. How's everybody? Looks like not much going on just yet. So, yeah, we'll just keep going. Keep building more of these methods. Okay. So, next up, now that we can increase the bounty, and we've done all the bounty increase stuff, is approving bids, right? But I think the logical progression is not to approve a bid. But rather to submit a bid as a furnisher. That's the next thing that should happen. Yeah, I can place a bid. Okay. Let's try to place a bid next. So I want a method. And when I place a bid, I just have to require stateful propagation. So once again, sig hash. Anyone can pay single. Okay. Async, we'll say furnisher places bid. And furnisher sig bid. I think we have that type available. So the furnisher places this bid on this contract. Anything else? Nope, I don't think so. Because we have the bid. Okay. Whoops, I just deleted 2 characters. All right. Here we are, and what are we going to require? Well, we're going to require that the mode is initial, because no bid can be, well, first, let's think. The same furnisher can put in multiple bids. We're not going to enforce that at the chain level, right? You just accept the one that you want out of the bids that were placed. Maybe they have different data or something. The first thing I'm going to say is state must be initial. Okay. State must be initial. Signature must be valid. If it's a bounty, we also want to assert that the amount is equal to the amount in the bounty. Otherwise, the bid amount just needs to be greater than or equal to the minimum. Okay. So now we verified the bid amount is valid, that we have a contract that can accept bids. Now, do we know do we even have a variable to track the total number of bids? Can we see the size is a function? Uh-oh. Are we going to run into like... Oh. I'm going to say that the number of bids plus 1 may not be greater than the maximum number of bids. Then we add the bid. And then we do basically this, grabbing the stateful UTXO and adding it forward. Hash outputs, whatever was in there before. Okay, so this is how you bid as a... Are there any other constraints that we're going to miss? Here's the thing about Script. You have to get all the constraints. Otherwise, bad people can and will and have an extremely strong financial incentive to do bad things. So remember that when you write contracts. Otherwise, you will get hacked, and it will be a bad day for you and for me and for the entire Metanet. So don't write terrible, unsecure contracts. Get your code checked out by other people who know how to check out that sort of thing. Contract must be in the initial state. The bid needs to be signed. The contract, if it's a bounty type, the bid value needs to be for the number of Satoshis currently in the contract. Otherwise, it needs to be more than or equal to the min bid. Then you make sure it doesn't go above the number of bids that we currently have in the system. Then the UTXO moves forward. I think that is, I think that is correct. I don't think there's any other issues with that. Let's go back to our pseudocode. So I can place a bid. So yeah, all right, reasonable. Let me read through some of our args just to refresh my mind about what we're dealing with. We're not going to think about things like the deadline yet, because only a fool would bid on something that, or should we? No, the onus is on the person not to submit a bid when the deadline is too close. All right. All right. So the required bond amount, that's what it is. So we got furnisher bonding mode, and we want to enforce that in this context. Okay. And we want to make sure bounty solvers need approval is true. Yeah. Bounty solvers need approval. And then the bond mode and bond amount. Approval isn't relevant here. We did bounty increase and the type. All right. So firstly, yeah, we have to require when they bid that, because you can't bid on something that you have to bounty solvers have to require approval if you want to submit a bid. The next thing we want to verify is all the things related to the bond amount. Okay. So if let's do the easy one first. If the bonding mode is forbidden, then we're going to assert that the bid is having no bond. Otherwise, if it is optional, then we're just going to require that it's more than or equal to 0. Because you don't want to set a negative bond. If you did, then when you post your bond, the contract would allow you to take out some of the money, which is a negative. There would be some interesting implications to that, but yeah, you can't do that, even if it's optional. All right. And then otherwise it's required, and we're going to assert that it's equal to the required bond amount, and we're also going to assert that, just to make sure that the seeker doesn't try any funny business. And we'll say greater than or equal to 0, because I guess you could require a bond amount of 0, which would be the same as for bidding. But yeah, that's whatever. Okay, now we have implemented all of the stuff with respect to a bond amount that would be required with a bid. So when you bid, you bond according to what is required by the contract, and we have that, and we required, yeah, it's not related to approval. Okay. All right, now we have the ability to place bids on a contract. Making some progress here. Okay, we need to move on to the acceptance of a bid. So I think when it comes to that, oh, and then, yeah, we're already verifying that, and we're in the right sig hash. Okay. So furnisher places bid, seeker accepts bid. And then, of course, platform can accept bid if that's allowed. There's a lot of constraints in here. So what bid did the seeker accept? Well, it should be, okay, and then I just thought of a type change. I don't think we track, let's see, do we currently track the bid that was accepted? Is there like an accepted bid anywhere? If so, Okay, seeker key, platform key, furniture key, work completion, state. Nope, nope. Okay, so we do need to track something about which bid was accepted. And I don't know the best way to do that with a hashed set. I think there's some off-chain value stuff, and I'm going to have to look at the Bitcoin CPU code to see how that was done in the past. But we're going to want to think about how, okay, for a seeker to accept a bid, a few things have to be true. Well, the state has to be initial. There has to be a need for the approval to happen. And this signature has to be valid, same as this. We already validated all the bids that can be placed, so we don't need to validate that again, but we do need to make sure the seeker signs. So the seeker can now know, okay, we know that in order to accept a bid, state has to be in initial. No approval is required, and then we have to make sure the bid is actually in the list of bids. What do we have here to work with? Has, attached to, clear, data, delete, difference, entries for, I think has. Yeah. Yeah. Should be able to tell us for sure that this has, and let's checks whether elements exist in the set, can be called in the method function. Good. All right. We're going to make sure that the bid they want to accept exists within the set of bids. Then oh wait, is there an attack vector here? Let me think here. I'm just thought of an attack vector. If I as a seeker wait until my deadline is fast approaching, and then I accept a bid, there has to be a minimum amount of time. Ah, yes. Yes. So a bid needs to stipulate the time that is required in order for it to be completed. Okay. Right. Right. Because otherwise, you could accept a bid even after, if the contract was just in the initial state and then the deadline passed, right? We want to ensure that there is enough time. So bids have a time required which must be non-zero. So let's update our type here. I've got to make sure that everything is going to work properly. We have a time unit already, but we're relative already, so this can be done without that until we actually go and check everything. We got to assume everybody's in the same time unit here. But then what I can do to make this work is when I am placing a bid, the bid needs to be right. I'm going to say if you place a bid and you say that the time that you need to do the work is more than the currently available amount of time between now and the deadline, then you can still place your bid. It's just that it can never be accepted. Because what I'm going to do now is I'm going to assert that the bid that was accepted I have to think here. The current time must be less than the deadline minus the time required, regardless of what unit we're using. And the time required must be in the same time regime as the units. And if you are exactly equal to 500 million, then you lose always. It's not allowed. I don't care what, I don't know which way it goes. Is it equal or less than or greater than or just no? Okay. What I'm saying here is your time unit for your bid must be compliant with the time regime of this contract. Then we're down here and we're saying that, sequence needs to be enforced, lock time needs to be enforced, and the lock time of this contract now, could I sign this? Oh, yes, I could. Here's the thing about lock time. If you sign with an older lock time than the current time, your transaction is still valid. If you sign with a newer lock time, you cannot do that. What we want to do here is we want to make sure that, so because the seeker is the one signing here, he could get past this constraint given that lock time is not properly enforced this way, right? I could sign this with an older lock time and the transaction is still valid. What I want to do is stop the parties from being able to screw each other over, but the thing is, it's not like that. The parties have to do their due diligence. If I just want to stop the seeker from accepting a bid right before a bid cannot be accepted if, is it relative? Is it the time required for the work, or is it, Yeah, it would be in the seeker's interest to sign with a low lock time value here, allowing the transaction to be considered valid on the network. So what we have to do, a bid cannot be considered acceptable, meaning a seeker may not accept a bid if the amount of time required to complete the work has, right, so getting time, what you can do in a contract is say, after this time has, we're trying to go backwards and we can't, Bitcoin doesn't let us do that. We're trying to say something like the expiry, we're trying to put a time limit on something. You can say not until, but you can't say not after. Can you? Somebody will always sign before. Now, ideally, the network would reject. Interesting. Yeah, ideally, the network would reject transactions that are from way long ago that have been valid for a long time with lock time values. But I don't think that's how it currently is in the real world. Yeah, if I sign with something, it should need to be current or reasonably current, right? It's just a little quirk of the protocol. I understand. Okay. So yeah, the problem remains. How do I make sure that a seeker cannot accept a bid immediately before the deadline, and then, well, let's think. Would I not simply let's see if this happened. If a seeker did manage to accept a bid at this juncture, work hasn't started until the furnisher posts bond and starts work. If I, as a furnisher, will not post bond because I know that my amount of time is limited, right? So seeker could do this and backdate, and it would be obvious to the network in case any disputes were to happen. The platform could look at what block the transaction made it into, and what you know what what the seeker is trying to sign with, what lock time they signed with, and say, well, you signed with a block that was 3 weeks ago. Why did you do that? Okay. Then the furnisher would need to accept the work still, and we'll have this. Maybe we'll have the furnisher also include a signature with this assertion, so that everybody agrees to start work, or everybody agrees there is enough time, right? And then we can look at that. It creates an interesting variable for the platform to evaluate in case of dispute. So basically, we can't stop this, but we do have to remember that in this case, the furnisher would need to start work and post bond and everything. This is just a bid. If I wait a year and then accept your bid after a year, doesn't matter, because in that case, you haven't put up any money yet, and you don't have to start work. If you don't start work, even though I accepted your bid, well, if you're the seeker, you can cancel the bid after a delay. There's that delay there, and we'll have that logic in just a second, right? But there's also the idea that if I do start work, I still have to bear in mind that deadline applies. So if I'm willing to do that and submit the work before the deadline, I can. If the deadline is close at hand, or even in the past at this point, number one, I'd have to sign with a lock time that acknowledges the amount of time I stipulated in my bid, meaning I'd have to sign with a past lock time, as with the seeker, because we'll have this check in the other one as well. And then number two, yeah, in case of dispute, I've sunk into their level at that point. So I might request them to extend their deadline and create a new contract if I really wanted to, make sure everything's on the up and up, because they originally said something and then they took so long to accept my bid that, gosh, go make a new contract or something, right? Maybe one thing I should enable is for the seeker to extend the deadline, the work deadline. That would be good. Because that way we wouldn't have to create a whole new contract. We could just the seeker could come along in the initial state when there's no bids yet. Actually, all the way up until, there's no real issue with the seeker deciding on their own volition that they want to extend the deadline, all the way up until work is submitted. The platform doesn't have that power, but the seeker, they're the one that originally set the deadline. So if they're willing to extend it, let's make it happen. So, let's see. We have furnisher places bid, but before that we have platform increases bounty, and we have seeker. I'm going to copy this guy here just because it contains some of the elements we want. Some of the state enforcement, we'll make it simpler, but the seeker can extend the deadline required for work if desired. Seeker extends okay. So just thinking through this here, right? Extension. We assert that the extension is more than 0. We don't care if it's a bounty or what. I think it doesn't matter, because if it's a bid or bounty, then work still needs to be done by the deadline. We know that, okay? Then we're making sure that there's no restriction on this. It's not a permissions thing. It's just generally the case that seekers can always increase the deadline if they want, to give people more time to continue working or whatever. And eventually, you could enforce, like, if they, I don't know, you could do other things, but we just want to say the state needs to be initial bid accepted or work started. After work is submitted, it doesn't make sense for them to extend that deadline. Why would we restrict it? It's either this one or this one. I think it's the third one. Yeah, you should only be able to extend deadlines until work is submitted. Otherwise, you could say, "Oh, well, I'm going to extend my deadline," and then you've already done your work, but you had so much extra time, right? You get to make it like that. So instead of doing all of that silly nonsense, we should just do this one. Whoops. So, enforce the state constraint here. So we're going to say we require the extension to be more than 0. We require the state to be, once again, in one of these 3 states: initial, bid, or work is started, but not submitted. After they submit, doesn't matter. We want to make sure that the time regime of the resultant value is not insane. So if the contract is blocks, then I'm going to otherwise it must be greater than 500 million. Okay, so now we're asserting that if the escrow delay unit, we're enforcing that if you're going to extend as well. You can't enforce it at the beginning because anybody can create whatever locking script they want, but if you want to make the transformation, now the logic's here. Then we make sure the state is there. Check this signature from the seeker. Keep the same amount in the UTXO, and obviously increment the value. Okay, so now we have the ability to give people more time if we're the seeker, and we can move on to this. So we're thinking about the ability to accept a bid. We need a place to put the accepted bid, and we need to transition the contract into accepted bid state. Of course, that doesn't exist yet. We can make it as a property. Could be null, of course. Accepted bid. And we're going to model this as could be a bid or nothing in case it doesn't yet exist. And then down here, we got to set it explicitly to nothing because there's no accepted bid at the beginning. Okay. Confirm that makes the little red squiggly go away. Sure does. Accepted bid is now equal to bid. Obviously, we want to require our constraint here. What else is required when you go and do the when you go and accept a bid? Well, let's think. Again, we're sig hash single. Sig hash anyone can pay, but you can still do end lock time and end sequence assertions with those sig hashes. So it's good. Let's think. So to accept a bid, we must be in the initial state. Bids must need approval. The seeker must sign the acceptance. The bid must be in the list of bids. The time that we're saying it is must be such that, according to the terms of the initial bid, there is enough time. So if I wanted to, as a seeker, I could extend, and that would be the correct thing for me to do. If I was going to lie, I could just sign and backdate my transaction by using an older value for end lock time. But the correct thing for me to do would be to extend the deadline such that they have enough time and then to sign it with the current time. Okay? Otherwise, we would have an issue. We set the active bid at this point, and we basically just say, yep, now you're good. Okay? But let's think. Is there anything else that we would need to do? The state now transitions to bid accepted. Is there a time value? Again, let me read all the properties. I want to make sure that we're not missing anything here because it's a lot of stuff that we're dealing with. But so to accept a bid, approval. Yes, I see. I see. Platform can also accept a bid. Do we care what the... No, we don't because that's enforced up there. Okay. So what I'm missing here is that not only can the seeker accept a bid, but we need to make sure in this case that the the approval mode. Right. It must be seeker or platform in this case, because we're saying the seeker does this. Now, the question is, what if the platform does it? A platform can accept a bid on behalf of the seeker if the contract stipulates such. Platform sig, bid, state initial. Bounty solvers need approval, must still be true. It must be platform, and the platform signature must come from the platform key. Verify the bid exists, and verify that the time is such as it should be, and verify and update the state, and build the value for the output. Okay, now the platform can accept a bid, and the seeker of work can accept a bid, either one, depending on the rules in place for this contract. All right, now let's think. To accept a bid is the next, is kind of the progression. I forgot something. In the placing bid method, we need to make sure that the bid time is correct. If we don't have the bid time being correct, what happens is we don't know when we have the ability to cancel. If we approve a bid, they have a certain amount of time to accept work where we can't cancel, where they can start work by posting the bond. But if we don't validate in the furnisher places bid method, the bid's time is correct, then you get to a place where it's not very good. We forgot basically the time of bid. So we're going to require that this is signed with a sequence number like this. And we're going to require that the lock time of this transaction is it less than? Yes, that's like a implicit. I think it has to be the lock time of this transaction must be greater than or equal to the time of bid so that the transaction may only be considered valid at the time of bid. It serves the bidder to put the latest time of bid because that gives them the most time. Oh, wait. There is the time that the bid was accepted, and there's the time that the bid was placed. The cancellation is relative to the time that the bid is accepted, not the time of the bid itself. Either way, we want to enforce that the time of the bid is correct because we want to know how long they have to see. We're thinking through this a little more. Okay. Right. We want to make sure that the units are correct. And then we want to make sure that the platform can, or sorry, that the seeker notes the time at which they accept a bid honestly. That should be another variable because then we can have a better mechanism of enforcing that. And then we probably want to change that to be a bid expiry versus a time required. Although we can implement both. How long does the bid expire? Or does a bid last forever? A bid lasts until the time between. Yes, we can compute that. A bid lasts until a bid expires 1 second before the time required before deadline, unless I extend the deadline as a seeker, in which case it may serve the bidder to stipulate an explicit time of expiry. When did I bid and when does my bid expire? I can check the when did I bid here, and I just have done that, but what I can do is, right, need to do this regardless. Obviously, this needs to be less than. Otherwise, it needs to be greater than 500 million. So in effect, all right, here we are. So that means the bid is here at this time. Can bids expire? How would that work? Yeah, I'm just thinking about, I mean, there is some protection already in place, right? You can't, if the time required to complete the work is more than the time available before the deadline must first be extended. Now, is there an attack vector where the seeker can extend the deadline before accepting a bid so as to provide enough time? Would the furnisher want to prevent their bid from being used in 1,000,000 years or something? Right. Could I stop that? Well, no, because I'd have to accept work. Just thinking through some implications here. We're now enforcing the time of bid properly. Let's consider the seeker wanting to cancel and how that would work. What I was originally considering was that I was originally trying to consider linking the time of bid to the amount of time maximum that must elapse before the seeker can cancel the acceptance of the bid, meaning there's a window in which the bidder always has the opportunity to post bond and start work. Obviously, they put a bid and they got it accepted, so they have that opportunity. Now, the issue here is that if the seeker simply waits until the way I was going to do that is I was going to add the delay time, the max work start delay time, to the time of bid, and ensure that cancellation can only happen after that amount of time. But is it the time that the bid was placed again, or is it the time that the bid was accepted? If it is the time the bid was accepted, then how do I ensure that the seeker is honest? Does it serve them to lie? Does it serve them to lie at all? I can always pretend it was the past. I can never pretend it was the future. That's how the rules of end-lock time work. Because I can sign something and get it accepted on the network for any past end-lock time. So as an author of a contract, I can only enforce things as, again, they're only, they're only constraints can only apply with respect to, not until, right? They can't apply in the other direction. So it's a little tricky. It's a little tricky, but let's think. I, as a bidder, am served by putting my time of bid in as late as possible. And if I just concede, the contract will, if I have a problem as a bidder, I just don't start work and I let it pass. The attack is that a seeker waits until say their delay was passed, but and then what do? They cancel my bid that they accepted. Yeah, I'm just thinking ahead into that function. Okay. And the worst case is my bid that they originally accepted got canceled because, oh wait, but they accepted it and then they canceled it immediately. That's not a consequential attack. Okay. I just wanted to think through all of the implications of that before we went any further, because I want to make sure there's not really consequential attack vectors here that I'm not considering, and I'm just trying to make sure we're covering all of our bases, right? Okay, we need a method where a seeker can cancel a bid. So let's go back to the pseudocode for the seeker. And Is that actually the same as? Interesting. I guess I didn't realize there's two methods here. So cancel, right? Verify the state has been accepted, and then state goes back to initial, and everything goes back to undefined. Got it. Ah, and I've also realized that when we do accept a bid, we need to set the furnisher key. It's important. Or do we, given it's in the accepted bid? I guess we don't need an explicit value for furnisher key if it is in the bid. Yeah, that's true. Better to keep it that way. All right, fine. But there's approved bid and approved bond. Let's see. Ah, of course. Of course. I forgot about that. Okay, couple things here. Number one, no more key for the furnisher because the bid contains the key. It's a redundant variable. No more furnisher key because, yeah, once again, we have a bid. That didn't exist before. Now it does. And then down here, we just get rid of it out of here. All right. Secondly, when a platform approves, or when anybody approves a bid, if it is a if this is a bounty type contract, then we're fine. But if it is a bond, sorry, not a bond, if it is a bid type contract, we have to put the money up, right? We have to make sure the money is there. And then here's the question. If the platform is the one to approve, is it the platform who goes and gets the money? How does that work? Who provides the money? Does it matter to this contract? It doesn't. All the contract cares about is that the money is there. So if the platform gets the money from the seeker or not, what we need to do is to we need to add some little constraints here, right? There are some little safety checks. How important is that? Just thinking. Yeah, there's a few things. For bid type contracts, there's a couple of am I not thinking properly? What if this and this and this? Probably better. We'll just do that. And then, yeah, the safety check I just want to add is that, you shouldn't put money into it before you. So as people are bidding on a bid type contract, there should only ever be one Satoshi in the contract the whole time. If it's a bid type contract, the no bid is accepted. The value, you're not putting your money in. Otherwise, somebody they'll mistake it. They'll throw money in there. They won't be able to get it back. There can only be one Satoshi in the contract. In fact, there must be exactly one Satoshi in the contract during the bidding process of bid type contracts. Now I can accept a bid, but if it is a bid type contract at this point, this is what I wanted to enforce. I want to enforce that if it's a bid type contract, so you're bidding, now the money has to be there. Otherwise, the amount of money in the contract cannot change. Now, here's the other exploit that I just found. Bidders could they change it? Just thinking. With this type of contract, they could change it, couldn't they? Because, no, we're saying the previous state, the previous number of Satoshis applies. Okay, that's correct. All right. Now, yeah, let's see. For a for a bounty type contract, you do want all the Satoshis to stay in the contract. Otherwise, you want to go from one Satoshi to the actual amount of the accepted bid. Now, the person, right? That's what I wanted to do. Now, the seeker who accepts the bid must put up the money. Otherwise, that would be a problem. So I'm going to put the same thing in the platform one. If the platform is going to accept the bid on a bid type contract, well, they're the one that owns the responsibility of making sure the money's there. Depends on how you set everything up, everybody. Okay. Money has to be there. That's important. Can't go ahead with a deal if it's not, right? All right, so what does it look like when the seeker cancels a bid. Seeker cancels a bid. So up to the state. Now the state is bid accepted. The seeker may cancel a bid after the bid time, after the time of bid plus the delay. And we're gonna, enforce the unit sanity checks again on everything. So everybody has to be more than 0. Just doing some unit sanity checks here. Everybody has to be more than 0 because otherwise really bad things happen and the whole world breaks. Okay. So this is a method with sig hash dot anyone can pay single. Seeker cancels bid acceptance. Seeker withdraws. Withdraws? So we need a seeker signature. And they can do this as long as the bid has been accepted. They are, in fact, the seeker. The time has passed. Lock time must be greater than the time of bid plus the work start delay. Lock time must be okay. I know that that is defined because the state is accepted. Why is it telling me I know that? Okay, this is TypeScript. I don't know if the script compiler is going to be happy with that. It might not. If it's not, I'll deal with that later. But that is the accepted bid. Okay, we know it's an accepted bid because we're in the accepted bid state. We can only get here when there is one. So we know that the time has passed. We know that the the seeker has signed. The bid was previously accepted. And if those things are true, obviously we have to validate the units. No funny business. I don't even know if you can declare variables in here. If you can, then I want to make sure that if oh, that would be a terrible bug. If it's blocks, then I need this value to be less than 500 million. Otherwise, I need this value to be greater than 500 million. Okay, then I'm going to do the opposite. Then I'm going to say, if it was a bounty type contract, the bounty is the same, must be the same, in fact. Otherwise, we're going to force them to withdraw the amount of the contract. Force it to be withdrawn. All right, get out of here. We don't want to have the money in the contract anymore and that also allows the bid to be placed. Goes back to state initial. Goes back to null. Who else? What did I do? Nope, state and accepted bid. Those were the only ones. Those were the only assertions. All right. Goes back. Everything goes back. And we're validating the approval mode, are we? Or are we not? Ah, we forgot that. Okay, so obviously you need to check that your solvers need approval. You can't cancel a bid if there's no, that doesn't make any sense. And you need to verify that the approval mode is being followed. And we don't check that it has the bid because it's already in the accepted state. Okay, so we just need these two assertions. And this is seeker down here. So we're going to confirm those sanity checks. We're going to confirm this one. And it needs to be seeker. Seeker or platform. All right, this is when the seeker is going to reject, or it's going to, withdraw a bid. And the platform, now, here's an exploit. Here's an exploit. If the seeker is the one to put up money, the platform could withdraw it. And if the platform was the one to put up money, then the seeker could be the one to withdraw it if there's the either or case. So we need to require that the seeker is the one to cancel the bid if the seeker is the one that was the one to put it up in that either or case. And that the platform is the one to cancel a bid if the platform is the one who, who is in the either or case. So we need an additional variable to track who put up the money, right? Because if it's the either or case, then that's the only one who has the right to withdraw the bid. You don't get to do that. The platform doesn't get to do that if the platform was the one to do that. So let's code that and then add the variable and then add the instantiation. Okay, let's see. So I want to make sure that bid accepted by seeker. All right, and then let's do the platform. Oh, and then we have to say that equal to up there on each of those. Okay, so coding up the platform. Platform withdraws bid acceptance. State platform signature, bid accepted, platform signature, platform key. Okay. Verify, verify, verify. That is all good. Yeah, don't lose. It's not a good thing if you do that. Okay, it must be the platform. And this is going to be bid accepted by platform. And then we'll set that in the up in those ones. Verify that the time has in fact expired. Set that to there and take the money. All right. So we're going to want to zero that out to bid not yet accepted. And that goes up here. And then when the bid gets accepted here, bid accepted by platform. And then this is when the bid is accepted by the seeker. That way they can't do any funny business. Bid accepted by, and then we'll set our variables up here. Bid not yet accepted. All right, and then of course in the constructor, the bid is not yet accepted. All right, that should cover that. So now you can place bids, and bids can be right. Yeah. Yeah, this makes sense. Okay, so a platform, right? So a furnisher can place a bid. Seeker can accept the bid. Platform could accept the bid if that's allowed by the approval mode. The seeker can withdraw the bid acceptance if the bid was originally accepted by the seeker. And the platform can withdraw the bid acceptance if the bid was originally accepted by the platform. Let's see. Is that correct? If the bid was originally accepted by the platform. Yeah. Okay. So now we have done the cancellation of bids. And we're at line 499. It's a lot. And the acceptance of bids. Okay. And we have this essentially done as well, because we account for when the money needs to be put up and when the money gets taken back down in that case. When can work start? Right, we did this for both the seeker and the platform. And we can only approve completed work after work has been started and submitted. So you start work, which means you have to post your bond. That's the next thing. So we're back to the furnisher for a little while. So you start and you complete your work. Okay. So state is in bid acceptance. Increase contract amount by required bond amount if bidded bond amount. Right. Or bidded bond amount if needed. Okay. So to start work, furnisher begins work. This is what's going to allow us to, not a prop, a method. Anyone can pay single. This is async. What? What? Oh, come on. No. No. Good. Nope. Have I lost my mind, guys? Is it finally happening? Is it finally happening? No. All the rest of them are good, right? Those were the only ones that were not good. We're fine. Start work. Man, okay. And the furnisher needs to sign to start work. All right. And before we go any further, I'm going to check in with the chat and the live stream and everything. See how that's going. All right. Yep. Keep on keeping on, it looks like. I think I'm going to wrap up pretty quick. I'll go for a little while longer, but let's see. To start work. Did I put an assertion about bond approval mode and everything in here? Just got to make sure. I'm asserting the state. Yeah, we are. Okay, just want to make sure. So we're going to need this in here too, right? If I want to start work, furnisher starts work. Obviously, we need to be in this state. Well, it's kind of redundant at this point. You can't get here, but, well, state needs to be in state bid accepted. Yeah, in order to start work, you need to have your bid accepted first. And then I'm going to make sure that the signature came from the, so the contract is in that place. You need it to be approved. Only the furnisher can start work. So checking the signature from the furnisher. Comes from, oh, for crying out loud. Okay. Comes from that key. That's going to cause a problem if Scrypt doesn't cooperate. I'm not going to run the build until the very end, guys, because I just like putting myself through more pain than is necessary. Okay. We might make this one the last method we do today. But furnisher starts work can happen when the furnisher signs and is the correct furnisher for the work and the bid is accepted. Is there any time constraint on this? I don't think so. The bond needs to be obviously factored in. We need to put the bond up. So if the bonding mode, or no, the bond is just the amount of the bid at this point. Like either it was 0 or it was not 0, but the bonding mode relates to how bids can come in. Now we have a bid and we're not concerned with validating that anymore. We're concerned with enforcing that. Essentially, is there any state that needs to be updated? I mean, yeah, obviously the state goes to starting work. So the value plus which may be 0. All these question marks and explanation points in this is going to make me lose my mind. The state, of course, needs to be updated first. State work started. All right. What else? You pay your bond, you start working. What gives? What gives? Anything? Anything. Anybody? Please help. Does the platform need to sign when work starts? Well, that's a that's a question. There's another configuration parameter that we should probably add related to whether the platform needs to sign. The reason why is because, well, what if the platform doesn't want to be involved? What then? And sometimes you want the platform to sign off. So there's some considerations there. Work description's already hard-coded, deadline's already there. Start delay, approval delay, delay unit. I don't think much else. The only thing would be if the platform sometimes also needs to sign, but the state just goes into the start of work state. If you were in a bid accepted state, regardless of time, right? We're saying regardless of time because we're saying regardless of time because the bid was accepted and not, the onus is on the seeker to withdraw a bid the onus is on the seeker to withdraw bid acceptance before the work starts if the seeker wishes to do that, and therefore we're not going to enforce that anything related to time has to happen when work actually starts. Right? You get to start work after the bid is accepted, as long as the bid is accepted. And if you do, then we move into this new state where you can't, you're acknowledging that everything is going to go ahead, and you're putting up your bond if you need to. All right. Now, the feature that I think we might want to consider adding here is platform work authorization. The platform might want to approve the starting of work by the furnisher. And it would be the exact same, except the platform now signs, says, yeah, this is fine. And maybe this is actually cool because it allows for the platform to post some of the bond. Maybe the platform helps bond furnishers in certain contract scenarios. And in that case, the platform can sign the output that is related to the bond because obviously some of the money could even come from the platform in that case to fund the contract. Keep in mind, we're cash single, anyone can pay. As long as that's properly funded, uh, it might work. It might work where the platform helps the furnisher by bonding them in case the in case the you know the yeah, that makes sense to me. So there needs to be another option that basically says, is this required, optional, or I think it's just either one or the other. You don't get to use either one. It's like the contract either requires that the furnisher is the one to start work, or they must use the platform. There's no like, oh, I might get authorization. No, you're going to get authorization from the platform. Like this is a thing that the platform would want to do. Um, yeah, yeah, that's pretty clear. All right. So what gives? Okay. So at the time the bond is posted, all right, platform authorization required is yes or no. It's very fundamental to the contract. So must the platform authorize start of work? And we're not going to even be opinionated about setting a default there. It must be 0 or 1. Or should we be opinionated? Well, it's like the service percentage, right? We're not setting a default service percentage because it really depends on who you're using for your escrow and what they're going to charge. All of that is part of the contract. Okay? You have to set that up. Must be platform authorization required in order to collaborate with the platform to start work. Otherwise, must not. Okay. So now furnishers can start work on contracts. I'm going to commit all of this code. And it's live. So now we're here. I think I'm going to call it for today. We've made a lot of progress on the logic, the implementation details for this escrow system. We've also made it a lot more powerful. Every time I work on this and think about it and write some code, it gets more and more powerful. So everybody, that code is now up on GitHub, and you can check it out at this repository here. We're going to continue building more of this. I'll probably do some of it on live stream and some of it, off camera. But let me know your thoughts. Let me know what you think of building an escrow system for the Metanet that will actually work in the real world. Because I guess that's where we all live, right? Anyways, it's been great. I've enjoyed this. Always happy to hear feedback from people about what you would like to see. But I think this would be a generally useful building block. It is extremely important that we build fun building blocks so that way everybody can play with them. But we also have to be careful. As we get into more powerful financial instruments, we have to ensure that all of our code is bulletproof, well-tested, and, this is research. I am a researcher, leading a research company, and I'm trying to see what's possible and get some basic proofs of concept out there. And I also want to do it in a very transparent way so that everybody can understand better about how all of this stuff works. We just need to ensure that these primitives are built and deployed, responsibly. And we need to do so in a way that complies with regulation and in a way that's going to work for the real world. Because once again, that's where we live. Thank you all for tuning in, whether now or in the future. And I will see you on the Metanet. Have a good one, everybody.